Hi y'all, it's Mrs. Blasky. First lecture video about Unit 1. Again, a lot of this is going to be review, but we're going to go about it some different ways than we did in Gen Chem. So topic 1.1 is talking about atomic structure. Now hopefully you remember that protons and neutrons are in the nucleus, electrons are around the nucleus, that we can write out the representation of our atoms based on atomic symbol, atomic number, and mass number. So mass number is the number of protons and neutrons. The atomic number is the number of protons. This is how those elements are arranged on the periodic table. And the atomic symbol there is the 1 or 2 letter abbreviation for that element. We write our atoms this way because there are multiple types of atoms of each element. Now, we know that an element is defined by its number of protons, but by changing the mass of that atom, we can still maintain the same identity because it has the same number of protons, but a different number of neutrons. We call those atoms isotopes of each other. So there are multiple isotopes of carbon. There's carbon-12, there's carbon-13, which has one extra mass, one extra neutron, and then carbon-14, which has 2 extra neutrons, increasing the mass by 2 from carbon-12. Very rarely are we going to see things written out this way in AP chemistry, but knowing the structure of the atom is going to help us figure out other things about the atom. So we're going to go back and re-talk about mass spectroscopy. We talked about this last unit when we were identifying empirical and molecular formulas. Mass spectroscopy can also be used to separate the different isotopes of an element. So previously we used it to separate the different masses of atoms. Different mass spectroscopers, spectronomers, can be used to separate the masses of individual isotopes. So when isotopes exist, especially naturally occurring, they do not all appear in the same abundance. So some isotopes are more readily available, some isotopes are much more rare. So those percent abundances are kind of the same as we traded the percent by mass originally. So we can take a certain sample, put it through our mass spectrometer, separate out those isotopes based on mass, and we can get a set of data that tells us how abundant each isotope is. Now, sometimes that abundance is just a number, sometimes that abundance is a percentage. And so we can see here for chlorine, chlorine has 2 main isotopes, chlorine-35 and chlorine-37. And we can see those relative abundances to each other. So that we can see that chlorine is about 75% of the mass of a sample, and chlorine-37 is 25% of the mass of that sample. So anytime we get this data for a single element, we can see the different isotopes that exist, even if they have a very small amount of abundance, but we can make a quick estimate as to what the average atomic mass of that isotope is going to be. For example, this is a graph of strontium, the mass spectrum for strontium. We can see that the majority of strontium is strontium-88. So the isotope with the largest percent abundance is strontium-88. There are several other isotopes that are less massive than 88. So we can tell that when we take the average of all of this information, that average mass is going to be close to 88, but is it going to be above 88 or below 88? Because these isotopes are smaller than 88, it will be slightly lower than 88. So we can just look at that as an estimate. We can also do calculations to determine what those average atomic masses are. So to find the average atomic mass mathematically, we take the mass of the first isotope and multiply it by its abundance, plus the mass of the second isotope, multiply it by its abundance. This is how we calculate your grades, right? A certain percentage is semester 1, a certain percentage is semester 2, a certain percentage is your final exam. We add all those together. So the average atomic mass, what we can calculate from this data, is the information that's on your periodic table. It's that decimal point mass number on the bottom of the box for each element. So we can work through these examples. We're actually going to work through these examples in class about how to draw that graph based on the data, and then also how to identify elements based on their graphs. So hopefully this was a nice short video today. We'll continue working on this in class, and I'll see you later.